Hello, welcome back to Daily Dose of Rust Language. In the part 2 of error handling in Rust that we covered yesterday. So we covered how to handle a recoverable error and then also an unrecoverable error and why you might need any of them. You can check out this video here. Now let's take a look at something very unique today, which will be the try operator. That is this sign, the question mark. It is similar to what you have today on TypeScript, where if you're not sure if something is there or not, but you don't want to check, then you can use the symbol. From the example we looked at yesterday, where you have a function that calculates an average of all the numbers inside a vector, but you also have another function that adds those numbers before you get the average. So for example, so this function accepts a vector and then adds all the numbers and return them. Then we have another function which we call getAverage, which will also accept a vector filled with numbers and then return the average. And you know, to get the average of a series of numbers, you add all of them and then you divide them by the number. So if you have 4 numbers, you add them and then divide them by 4. We don't want to do everything inside this getAverage, so that is why we have another function here. Now let's say for some reasons this add function might fail at some point, and so because of that we are no longer supposed to return just i32. In other languages, what you might do is to throw an exception if something goes bad, but in Rust we want the error to be recoverable if something happens. Therefore we'll just return a result of type i32 if everything went well, and if not, we can just return a string. Okay, can make it static, explaining what went wrong. Okay, now inside here, to get the average, we add the numbers first. You can just say let sum and then we'll call add and then pass all the values. Let's say 1 2 3 4, just 4 values. And since it needs a vector, we convert these values into a vector. Now the problem is that, as you know, since we are calling this function, it might return the value we want, or it might return a string. So usually we use a match statement to check what it is before we use it. But in this case we don't want to do that because we want it to be fast. So what we can then do is to just return the average, which will be the sum, and then we divide it by values dot length, which will be the length. So this will give us the average. But you see that Rust is also warning us because this is not an integer, it's just a result value. So what we can then do is to use the try operator right here. But now see what is really interesting. If we hover over this, it will say the operator this can only be used with functions that returns results or options, or another type that implements for residual. Okay, this is just a threat. So it's saying is this function that we are using this try operator in must return a result, and that makes sense because we are using it in place of another function that returns a result value, right? So it must be handled, and since we are not handling it, we need to be able to propagate that error. In the previous video we did yesterday, I also talked about error propagation. We need to propagate that error so that whoever is calling getAverage will then handle that error if it does occur, because you're not handling it here. So in order to take care of that, we need to make sure that we return. So I'm doing it this way so that you see what could happen, what the issues you could face real time. All we have to do is to return a result instead. But now the question is, what should we return when the error occurs? The value we are going to return should also match what this guy we are calling will return, this add. Because if it doesn't match that, for example, if you say i32, okay, if you try to say it's going to be i32, okay, so we'll see what will happen here. But for now, since we are now returning a result, then we must return a result, and in this case we can then return the OK variant. And as you know, we can use it this way simply because it has been loaded in the preload by Rust for us. So this is the equivalent of using results and saying okay, so it's the same thing, but since Rust has loaded that for us, we can just use it directly. Another issue you might run to you might run into is what we are seeing here right now. You can see that if we hover over this, Rust will say the try operator couldn't convert the error to iterate2, which simply means that this function that we are using, if an error occurs here, is going to return a static string slice for us. But right now, what we are returning from this function, which is what we are returning here, cannot be automatically converted to iterate2. So it might sound complicated, but it actually makes sense. So whatever it is that we are returning here, if an error occurs, the return type for that error must match what we are returning here. Since we've decided not to handle the error, whatever the error returns must be the type we will return for our own error inside this function. So what we can now do is to change this to static string slice as well. Now that error is gone right here. You can see it's no longer there. Now another real life situation here, because it's important that we do it this way so that as you code in Rust and you meet these errors, it will be easy for you to handle. It's pointing out that this len function right here returns a usize and not iterate2, but our value right here, when it is correct, will be of type iterate2. And you know Rust cannot add two values or divide two values that are not of the same type. So we need to somehow convert the I size that is or the usize that is being returned by this len function to iterate2. And what you can then do here is to say as iterate2. You can enclose that inside a parenthesis, and that will be fine. So that way we will have solved this. Now you can see one of the reasons why people think why people see Rust as a very tough language, because of some of these barriers, right? So as a quick recap, we have this function which returns something for us, and I want to demonstrate how to use the try operator in Rust, which is just this question mark. It works like that of TypeScript, where we know it's going to return, like in TypeScript, if you have an object and you don't know if that key will have a value inside there or if it's going to be a null, then you can use this operator to before you read what is inside it, okay, so that it doesn't throw an error. The same thing we are doing here. Okay, we have this function that will return a value for us. It will return a result value because something might go wrong and then it will no longer work very well, but we want the error to be recoverable. Therefore we are returning a result here. If it is successful, it will return a value of type iterate2. If it is not, it will return a string. Okay, but here we are using the function. The function will return whatever it calculates. It will add these numbers and then return this value right here, and we'll store it here, but it will actually return a result. Now the first problem we had is that we have to change the iterate2 value we had right here to return a result itself, so that whoever is going to get average should now handle the error we didn't want to handle here. Okay, if we wanted to handle it, then we would have used a match expression. Check out that video where we explained match expression. We would have used the match expression to match whatever is going to be returned here, but because we don't want to do that, we then propagate that error to whoever is using this function. Okay, now in order to do that, we have to return a result. That is the first thing we have to do. Now secondly, we have to return a result as well, because we are just returning what we were dividing. Using the OK variant, then we return a result that we say it is OK. It's like in TypeScript or JavaScript, when you have a promise and then you can call then on it when it is successful, or pass a function that will run when it is not successful in the catch block. So exactly something like what we are doing here. It's exactly what we are doing here, but we are using the OK variant to signify or to signal that this value is correct. And I also explained that this OK variant, we can also use the options, type in the options before it, but it's already loaded, so we are returning, you can just use it directly. Now we now run into some problems here because we are trying to add a usize, which is returned by this guy len, with an iterate2, which will be returned if it is successful. So we have to convert it to iterate2, just cast it somehow to iterate2, and Rust will take care of that, and then we'll return the value. And now lastly, we ran into some issues, and you have to pay attention to this whenever you are using this try operator. Whatever the error you are running away from that you don't want to match here, okay, you have to make sure that that is the type of error you are returning. You can see that we are running away from handling the error this guy will return. This add function will return, and it will return a static string if an error occurs. So since you are running away from it, whatever we are returning here must be of type. If an error occurs, it must be of the same type. If not, it's not going to work. And that means that if you're also running away from handling another type of error here, the value is returning must match the value this one is returning as well. Okay, so it must match the string. Now, as I explained in the other video when we treated enum, you can expand your ability to handle more by returning an enum here with different variants. Okay, you just have to specify it and then return the appropriate one whenever you need to. Okay, so I hope this is very clear, guys. If you still have more questions about this try operator, leave it down in the comment section or get to our website dailydoseofrustlanguage.perere.com. See you in another video. Remember to subscribe and like the video as well. Thank you.